Hello, this is the second part for the Greyboxing for Architectural Modular System tutorial. And in this tutorial, we're going to take a look at interlocking brick systems and future-proofing your Greyboxing in order to accommodate various pieces of different sizes and different variety. Okay, so in front of me is an extremely simple Greyboxed system. Let's take a look at these examples. So we have a straight vanilla piece with no detail whatsoever. Okay, so this is the floor, this is the wall. And then we have an outside corner and an inside corner. Okay, just that. We know that these things fit together really nicely. Okay, and probably in order to accommodate all these twists and turns, I will also need a piece that is just 1 meter wide, because otherwise in creating an interior space, an enclosed interior space, I will probably hit a snag and need a 1 unit long, let's say 1 meter long piece as well. But other than that, everything is fine. And then we can get into a stage where the Greyboxing starts slowly to turn into the objects themselves. Like, this is still Greyboxing, this is by no means detailed, or there is no reason to believe that this will be the final object. It is relatively simple and it is unfinished. It is in a very raw state. Okay, so what I want to draw your attention to in this tutorial is that when you're making decisions in terms of how the objects will connect to each other, will attach to each other, sometimes breaking the conventional limits of Greyboxing, or the Greybox outlines, the sort of bounding box defined by this area, breaking those limits and encroaching upon other objects which they will interact with, might be the best option to go. So this explanation might not mean anything, so let me explain through visuals. So right now, as you can see, all of these objects stay fairly well within the limits of this area, the gray boxed area. As you can see, each and every single one of these objects never intend to break the limits. They are approaching the limits themselves, but they are never going past that. They are never going beyond that. And this is the safest approach. And as you will see, these things will meet each other really neatly. There's nothing wrong with this system. Okay? But here's the problem. Now, this is where future-proofing comes in. You have to imagine completing these objects as assets and texturing them and, you know, putting on materials, and then start blending them together, start pairing them together in order to create level designs. Now, if this was intended to be, for example, a really manufactured, factory-made, up to the standard, let's say, object of sorts, or an architectural object of sorts, like in the case of a concrete or steel or whatever, right? More modern materials. I'm talking about more modern materials. Then everything is fine. Probably we would hit a snag every few moments here and there, but otherwise we wouldn't have many issues. But if this was supposed to be as I intended to be, for example, a more organic material like wood, rocky surface, or you know, handmade brickwork of sorts, where it would contain sort of details that would, for the sake of variety and you know, the visual flair, break the general outlines or the general shapes of the geometry of the asset. That it would have organic details, for example, they wouldn't match together, especially in the texturing department, because right now, as you can see, this face here, this here, is intended to act as a single face. This means that whenever you you know, cover this geometry with a texture, you would have to create a texture that would match, for example, the other part's texture on the other end. which is quite challenging, right? So if we were to design these assets in this fashion, we would have future problems in the texturing stage, and then when we bring these objects together, they wouldn't necessarily match each other. We can combine them still, and from one perspective, from a geometric perspective, they would work. Even if we are using these assets, they would work perfectly, but the texture on them will probably have very obvious seam lines, because trying to match these textures, especially if you're using high quality textures with lots of room to show that seam line extremely clearly, you would have issues. Not to mention, if this was going to be in a higher polygon density, and then you would go in with your sculpting tools and mesh some details in, you wouldn't be able to match the smoothing lines as well. Now, this is a very hard surface because it was designed as such, right? It has hard edges, as you can see, very hard edges. That's good, that's fine, but what if I want it to be slightly organic? What if I wanted to have some smoother effects around the edges? Now, when it comes to here, they wouldn't necessarily match. It would fail, okay? So in that case, we need to look at the example of interlocking brick systems. And what better way to understand interlocking bricks and how they work with the modular system without breaking the modularity of the pieces than Legos, right? Legos are the perfect analogy for interlocking brick systems, because they are, for all intents and purposes, interlocking brick systems. As you can see, this is the module itself, the face of the brick right now. For example, this is 3 plates high. That's the modular system of Legos, right? This thing is the module itself, but there are studs on top that break apart that convention, but no need to worry, because all of the bricks also have holes underside that can receive those snots. No, sorry, snot is a building technique, those studs, right? So the studs will disappear. Studs will disappear into the modular system itself, and when you attach them together, the modular system works perfectly. They simply attach together. That's it. So we can design our own gray box with the same methods. Instead of trying to break apart objects right at the middle of them in order to fit them together, and that way risk not being able to create convincing or good-looking textures towards the end of the project, instead we can, solve this problem earlier on, and instead of modeling them like this, we can model them like this. In this case, let me hide this wall, because this is another thing that I want to talk about. Okay. In this case, for example, as you can see, every part of this system has some part, especially these vertical pieces, that protrude outwards from the module. But in the meantime, all of them have empty spaces defined within the opposing module that allow for this piece, let's start with this one, to snap in. Okay? So basically, this is a complicated Lego piece, or not a complicated Lego piece, it's just a Lego piece. It's a simple Lego piece that doesn't look like a Lego piece, but for all intents and purposes, it behaves in exactly the same fashion. Now, since this part has its own dedicated texture, right? And clearly the building technique dictates that since these are intended to be wooden pieces, and I'm going to show you my references now, since these are intended to be wooden pieces, and since they are made out of different wooden pieces, I can separate them really easily. So let's take a look at the reference files and also what I intend to do with this system. Okay, so these are my references. These are old mine shafts, old gold mines, for example, from not even turn of the century, like 19th century, even 18th century, going as far back as 18th century, especially in the United States. And I'm not trying to exactly model these things, but I am drawing heavy inspiration from them. And in the end, I want to have a modular system with a rocky face, like so. here a rocky face, a separate object with separate materials that I can control independently of this modular system, but we built with the intention of fitting it in the end, and I will explain, right? I want to have rocky faces, but at the same time I want to have wooden logs, or maybe in this case not logs but 20 by 20 wooden beams and wooden columns that fit together. Okay, maybe even haphazardly thrown together. Right now they are very straight, very vertical, very parallel. They look really neatly and nicely built, but I can break that apart later once I get the hang of things. I can create extreme amounts of variety once I make sure that everything fits together snugly. Okay, so let me show you where this leads. Now these are low poly versions of the system. This is no longer greyboxing. We are past the greyboxing stage, and we slowly started to build these pieces together. Don't worry, you're not going to make these for your midterms. Okay, I'm just I intend to show you these because I want you to understand how this is going to progress. Okay, so in this case, as you can see, I have modeled the corners with bevels. Okay, I have slightly smoothed out the details, and once again they fit together really nicely. And as you can see, in order for this system to work, you have to not mirror any of these objects and just attach them side to side, while only doing certain rotations, like 90-degree rotations. Always 90-degree rotate. You can rotate in either direction. It's not going to break the system, but you shouldn't mirror, because if you were to mirror these objects, obviously the protruding piece and the receiving empty area, so to speak, would swap and the system would fail. Okay, so while modeling them, you should always put the interlocking pieces in the same direction. It could be either left or right, doesn't really matter, depending on the situation, depending on what you want to achieve, but it should always face the same direction. Okay, and I have created additional pieces as well. So for example, this is a U-bend, a U-corner, right? And my walls will always have a thickness of 1 meter, because this is a cave system. I can get away with huge thick walls. This is not meant to be an apartment building after all. I also have a column piece. I have a 1 meter long piece, and I intended to do a door, but I'm in the middle of creating these parts, and I will further upgrade, let's say improve this entire set, and maybe in the end you will see the finished product as well. I intend to do that. Okay, so after you complete this stage, you can obviously what was the term? You can not quadrangulate, but yeah, retopologize this surface, right, with a certain amount, with certain settings, and this will create automatically a more organic feel to what you're trying to achieve. Then you can add additional subdivisions to it to further smooth out the surface, and then sculpt all of these details, all of these wooden details, as you can see, right? And then you can export this model as a high poly mesh, and you can export these as low poly meshes. That way, obviously with the UVs, as you can see, I have started creating the UVs as well. Okay, and I will explain further how you can stack the UVs in a different tutorial, like so. Multiple meshes, all sharing the same UV space, but without encroaching upon other UV sets or other, let's say, UV regions, or not UV regions, but UV shells. Okay, all the shells are separate, but all the shells belong to a different object, but they are sharing the same UV space. That way I can create a single texture, and I will know for sure that single material will be applicable to multiple pieces across the board, perhaps to the entire modular system. That way I am optimizing the process heavily. Okay, so let's turn off the UV editor, and this is how the process is going to continue. But in order to get here, in order to make sure that this system can work, right, that this piece, for example, can meet other pieces like so, in order to make sure that this works, right, I have to design it from the very beginning as such. I have to foresee the problems, and one of the problems is obviously texture repetition or texture tiling. So be careful of that. That's why we do interlocking systems. So let's look at a more subtle example. Let's look at a system that you can easily understand and start to model and perhaps apply in your own work. So I'm going to reveal something else. What I have here is really similar, right? I have another Greybox system, and once again, this is an interlocking brick system, and the funny thing is, it is also a brick wall. Now, this behaves like a brick system, as in Legos, but in the meantime, itself is made out of bricks, or it looks like it is made out of bricks. Something like this, okay? So, let me hide all of that, and let's model from scratch. Okay, so let's pull this to the side, maybe like 1000 units on the z-axis apparently. Okay, and start to model our brick wall. Now, the best way to do brick walls is to obviously stagger them, because if you search for brick wall, obviously this is what you get. So let's imagine that you're doing the most boring, most common brick wall there is, like half staggering bricks, right? There are different types of bricklaying techniques, obviously. Some of them look more complicated, some of them look more fancy. You can do whatever, and you don't always have to, by the way, model bricks. You can use just simple textures or texture painting for brickwork. I just wanted to show you how the system works from a geometrical perspective. That's why I'm using the example of bricks. You don't have to model your own bricks or anything, but if you want to, you can do that. That's entirely up to you. Remember, the technique and style will be your own. Okay, so let's start modeling this thing. So what I have here is a 2 meter by 3 meter wall, which I intend to model, and I'm not going to bother with the ground, okay? But all of these systems have appropriate zones for laying floor work of sorts, floor tiles. So if you want to do that, you can actually achieve that look. Maybe in a future example with this mineshaft example, right? We're gonna see that. But until then, let's just focus on the brick wall. So I'm going to create a basic plane. Let's bring it over here, okay? And then I'm going to just give it a width of 200, or let's do this and that, okay? Let's, just rotate it. Okay, put it in here, push it just a touch so it stays on the grid so we understand what's going on. Okay, then I will have to think of my brick pattern, because this is going to be a repeating pattern and I want to be able to control it as cleanly and as neatly as possible. So working with grid, working with known dimensions is always to your advantage. So perhaps we should do that. So within 300 centimeters, I can easily fit, I don't know, 20 bricks if every brick was 15 centimeters high. So let's perhaps try that. Subdivisions height. Oh, not this one, apparently. This one. 20. Nice. You can do that. Or you can go with 15 bricks. 15 is much, let's say, simpler number. 20 centimeter tall bricks. Now, they are no longer bricks. Nobody makes 20 centimeter tall bricks. That is not a standard in any means in any part of the world. So these are more like briquettes. These are more like stones now, stonework now, but whatever, we don't care. Okay, and yeah, they look really nice. So what I'm about to do is very simple. I want to create Lego bricks out of these so that it matches its own. So what I'm going to do is just grab a bunch of faces from one side, delete them, and then grab a bunch of edges, the opposing edges, from the other side and extrude them. It's that simple. Okay? There you go. This is the system. And let me put this pivot position, pivot point, in a corner, okay? And using your pivot position in a known point, not in the middle but on the corners, is preferred because it is easier to control the modular system that way. One side is always on the pivot position. Like not knowing the distance to either side is harder to control. This is much easier. It is usually done this way. Okay, now I'm going to make a copy of this, put it on this side, and make a copy of it and put it on this side. Okay, so what I can do here is very simple. Just grab these vertices, okay, and I can even put my local pivot position, like the selections pivot position, in here on this corner, okay, and then just grab a rotation, and this is the Y rotation, and it's going to be going in a clockwise, sorry, counterclockwise, so that's positive. No, that didn't work apparently, because yeah, these were already rotated objects, so I have to rotate on the x-axis because I already rotated it. So let's try it this way. There you go. Okay, and we can do the same here. Once again, select them, move the local pivot position here, okay, and then this time rotate it -90. Oh no, it was also 90 because it is still counterclockwise. And there you go. Okay, so then also I can go grab hard edges, delete history, and freeze their transformations, while also modifying the pivot locations so they are right where they're supposed to be. Okay, so here you go. Here is the foundation of your brickwork. Here's the foundation of the brickwork modular system in the form of a gray box. Okay, now let's keep adding details to it, see the results. Okay, I made a duplicate of that. So what I'm going to do is perhaps, grab most of these faces and delete them, because to be honest, I don't need them. I can just do, since this is a highly repetitive object, I can just do one row of bricks. Okay, I grab these faces, grab these faces, and grab these faces. Okay, I'm separating them because if I select everything and try to extrude, it is going to just extrude as one big thing, and I don't want to do that. Okay, and I'm not going to extrude anyway. I'm just going to offset. Okay, and let's offset like 1 centimeters. Okay, or perhaps 2 centimeters. Okay, and then I can just move them 2 centimeters in this direction, and this direction being -x. I can just do this. There you go. Now I can do the same here, like just grab them, okay, just offset them, and then move them in this direction, in the x direction, like so. Okay. Now I have one line, and now you understand why I have a middle piece, a middle edge going right through every single one of them. Because then if I just grab this and offset it just half a brick, the edges, the edge topology, as you can see, will perfectly match. Okay. Now I can combine these and merge the vertices and delete the history and put the pivot position in a known location, meaningful location. Control D to duplicate as many times as it's necessary. Let's check. I need one more, and since there were 15 rows and we multiplied in even numbers, obviously, in this case I'm going to just delete the last row. Okay. Just grab all of them, combine, merge the vertices. Beautiful. Okay, let's once again relocate our pivot position. This piece is ready. You can even consider this as the low poly version of your wall. If you want to add additional details, by all means go for it, but as a low poly object that you would see from far away if this was an isometric game or a low poly in the game of sorts, this is more than enough. You don't have to do much, especially if you're not if you do not intend to put, you know, huge hyper realistic amounts of detail, which isn't you know, necessary at this stage. We will do it eventually in the high poly version as well. So in that case, you would use the high poly version as the real object instead of using the low poly version anyway. So this is more than enough. So let's duplicate this and let's create, obviously, this version. Okay. So let's see what happens when we apply the same trick here. So let's select these faces. Okay. Make sure nothing else is selected. Okay. And it will probably not work as intended. So in this case, I would prefer separating this, rotating it, and then making the connection. And in that case, maybe doing it 2 rows at a time this time, because 1 row is different than the other. Okay. This will make much more sense once I start to do what I want to do. So here I will grab these faces, not these ones. Okay. Separate them, extract. Okay. And you can find it under here, edit mesh, extract. Okay. It is the opposite of combine. Basically, let's delete the history. Okay. And let's, because once you extract an object, the pivot position automatically resets to origin, as you can see, and we don't need that. So what I'm going to do is simply center pivot. Okay. So pivot insert, let's put it here, because that is going to be the center of my rotation in this case. So let's rotate it 90 degrees. And now we need to fill in the blanks. So what I'm going to do is obviously consider this system as a combination of pieces. Okay, so this is a bit wonky though. Can you see the problem now? This is where future proofing comes in. You have 2 options. One, you have to break your system and consider this problem as a challenge and modify it accordingly. And otherwise, you can go on as if nothing has happened, because if you go on as if nothing has happened, that's perfectly fine, but sometimes you will not get the best results in the end. But maybe taking on this challenge and trying to solve this problem can be more fun. Can you see the problem already? Take a look at the bricks. This has a long side and this has a long side. This has a short side and this has a short side. They would need to have opposing sides. This needs a short side, this needs a long side, or the other way around. But on the other hand, these pieces match. So if I change this, I should also need to change that. I mean, it would automatically change if you just, you know, stagger this. Half a brick, it would work, right? It works if you complete these missing areas with the correct stagger, right? It would work. But now I have not only moved my, let's say, stud, the additional brick piece, out of the modular system, out of the initial gray box, I also moved an entire brick's worth of it. So this is getting interesting, right? So how do you solve this problem? Like I said, you can modify this piece in order to hide the crime and still stay within the module. That's one option. Otherwise, you would need to break apart your entire modular system to accommodate the correction for this mistake. So that's why we do things in the greyboxing stage in order to fix the problem. So for example, since this is no longer 100 centimeters, but the module has just become 120 centimeters, I would have to create pieces like 80 centimeter wide, or I would have to create a system in which offsetting it 20 centimeters would still solve most of our issues. Okay, and I cannot guarantee that. There's always going to be a problem. I mean, you can guarantee that, but you will have to create so many pieces that would fix that problem. So in that case, I would rather have the crime hidden away. And in order to do that, I'm going to hide the crime somewhere along here, as opposed to trying to hide it in here. I'm going to make sure that the corner, which is going to grab the most attention from a visual perspective, I'm going to fix the corner and make it as it should be. But on the other hand, I'm going to also modify this area to accommodate for the issue, let's say. So what I'm going to do is just delete these areas, okay? Just leave it here because I'm going to need this, okay? And then I'm going to put it in here. Now this part is matching, just short side, long side, okay? And then there's going to be a short side here somewhere. So I can just, you know, grab this, okay, delete it, okay, and then grab these and extract them. And let's go to that, okay, delete the history, we don't need it, okay, and put it in here. So now I have to match these surfaces together, which is very easy, okay. So, and obviously I have to, you know, create some accommodations for the new type of connection. Okay. And then I will have to match between these areas. So what I can do here is grab these, just extrude them, delete these corners. I can delete them because only two edges are meeting one vertex. In that case, you can delete a vertex, if you remember. And then snap these vertices here. Nice. Gonna do the same thing here. Just extrude it. Doesn't really matter. You don't have to, you know, use snap functions here because you're gonna snap in the end anyway. Okay. That's good. Now let's combine them and merge the vertices. Okay. Now what I have to do is somehow hide the crime here. What I can do here is basically use a one long brick or two short brick. One long brick and one short brick, or I can use two one normal brick and two short bricks. Basically, I can do both. Okay, so let's keep it simple, keep it relatively simple, and just use one long brick and two short brick, one short brick. Okay, which seems much easier. Let's do something like this. Okay. And basically what I can do here is just grab these faces, delete them, okay, and then grab these vertices, and since there's a distance of 20 centimeters in this direction and this is going to be minus x, I can just type in this, okay. I can then add this edge loop, snap it into position so it meets the vertex at here at this end, and it's going to meet any vertex coming from here, any edge coming from here. Okay, this is fine. Right, so let's make a copy of it, put it here. Now grab these edges, control delete them so no vertices remain. Let's push them back to their intended positions, and it's now minus 20. There you go. Okay. And now if we combine everything and merge the vertices and delete history, and let's put this pivot position here in a corner. Now we can copy and then once again, since we have 15 rows of bricks but we were multiplying in even numbers, we now have 16 rows of bricks. So I'm going to delete the last row because I don't need it. Okay, select everything, combine, merge vertices, delete history. Okay, grab the pivot position, put it in a corner. Okay, that's good. Now we have to do the same thing. This was the outside corner. Okay, now we have to do the same thing for the inside corner. Okay, let's start similar. Once again, delete every row, every extra row that I don't need, because I can always replicate it later. Oops, I deleted more than I intended to. Okay. Let's take a look at this example. So here, let's put it in. Let's rotate it. There you go. Once again, the same situation arises here as well. This wouldn't normally work, okay? And I would much rather stagger them, similar to what I did before, okay? So let's do exactly that. Delete anything that we don't need, okay? Like so, okay? Perfect. Let's come over here, okay? And then delete anything that I don't need over here. But in this case, I'm going to delete these two, okay? And also delete this as well. All right. Perfect. Now I can stagger this like so, as intended. Okay. But here's the issue. Okay. I want to be able to see a corner here. Like these bricks have, you know, depth relationship between each other. Okay. If I do this, they will be perfectly connected. I don't want a perfect connection. I want to basically do this. Like, let me open up Paint and try to draw from the top. Okay, like one brick is like so. Like this is the top view, okay? And this is the outside of the brick, okay? As seen from above, okay? And this is the brick next to it. And this is also outside. So this is the inside corner. This is the kind of detail I want to see. I wanna create a space here to imply that these bricks are put together side to side, similar to how there is a crease between each and every single one of them, to imply that these bricks are laid on top of each other and there is a small empty space right around the edges. I want to do something similar, okay? So since this is a full brick size, okay, and in this case this is a full brick size, I want to do something like this. I want to, like I said, maybe make one of them slightly smaller. In this case, let's try this. Let's go to bricks here. So for example, I want to do something like this. Like these were 2 centimeters. Okay, so this is the X direction, so -2 in this direction. I want to create an opening like this, okay? And I will need to fix this connection after all, okay? And I want to do the same here, okay? For this side. I'm going to grab these faces, okay? And I want to move them on the z direction, z plus direction, like so, okay? And then I will need to create further connections to, or let's say further modifications, so that they match each other and match anything that is going to come from the repetition, okay? Now this is slightly harder to get the hang of, but nothing you cannot handle with a bit of geometric trickery. Okay, so let's grab these vertices, snap them here. I'm basically filling in the blanks. That's what I'm doing, okay? So similar to what we have here. So perhaps I want to do something like this, like extrude this edge, but only towards here, and then merge the vertices to make sure that this point is connected, and do something like this, and do something like that. Grab these vertices, put them where they need to be, okay? And then, for example, create a connection between here and here to facilitate that matching empty space. Now I have to do the same for here. As you can see, now I don't need these faces, but what I do need is, once again, the extrusion of this edge in this direction, and then merge the vertices, because there are two vertices here right now. Take a look, okay? Because I just extruded an edge, so it created a further edge, but since I snapped it right on the vertex, it created a zero length edge. So unless I merge the vertices, it's going to stay there, okay? But now take a look. That vertex is just one vertex. No longer there's a second one there, okay? Is there a second one there? So let's do this connection, and let's make sure this part does the same as well. Okay, and you can simply do this as well. Let's take a look. Same here. Grab this edge, just extrude it, and then grab this vertex and delete it. Okay. Similar to what we did before, we now have to create, smaller pieces. That's easy to do. You can just grab one of these things, okay? Let's duplicate it. I only need this part, so if I select these areas and want to delete the rest, by shift selecting all of them, I'm going to inverse my selection. I'm going to just delete this, okay? I'm going to grab this edge. I want to move this 2 centimeters in this direction, though that's -2. Okay. Let's fill in the blanks. Okay. Let's put it here. Good. Duplicate it and put it here. Make sure that every edge matches the other one, and everything seems to be fine here. The connection might seem weird, but don't worry, it's going to all work out in the end. Okay? But we have to try. We still have to try. And yeah, we need to create an edge here. Okay? This vertex needs to be aligned with this line, because there's going to be a vertex coming here from the top once we start copying it. Okay? Now let's select these objects, independent objects, combine them, merge the vertices, and let's relocate the pivot position. Control D to duplicate, and once again duplicate as many times as it's necessary. And once again, since we have 15 rows, we need 15 rows, but we have 16 rows, we're gonna delete the last one. Okay. Make sure nothing odd sticks out. Grab all of them, combine, merge vertices, and delete history, and relocate the pivot. Nice. There you go. Okay. Beautiful. All right. Obviously, you want to name these files or name these objects, and better to do it now when the situation isn't complicated and the scene isn't crowded than later. Okay, so maybe this is brick wall set underscore. This is vanilla 2 meters, vanilla 2m. Okay, this is brick wall set underscore corner out. Okay, let's copy this, and yeah, this is corner in. There you go. Okay, let's try it. They match perfectly. Okay, and later down the line, obviously, you would start creating these additional elements, these high poly meshes, and as you can see, in order to accommodate for correctly surmising the normal map generation, correctly running the normal map generation, I have created a set of bricks larger than my final mesh, my low poly mesh intended for in-game use. I have created a mesh larger than that, and then I retopologized it and further smoothed it out, adding subdivisions. And this doesn't have any sculpting details on it. I just wanted to create this by retopologizing, because through retopologizing it is going to automatically create these small elements here and there, small artifacts here and there, and this is more than good enough. You can add your details if you want, by the way. You can sculpt those details in, but I only intend to use this for normal map generation and ambient occlusion map generation, detailed normal map and detailed ambient occlusion map generation in Substance Painter. And in the Substance Painter, I will put separate materials for bricks and the grout line, because the bricks will have a different color or a different type of material with different porous structure, and the grout line will have different grain structure, things like that. And the best way to separate them would be using this area where both the normal map, but more than that, the edge map, the curvature map, and the ambient occlusion map will correctly place gray lines, dark lines in here, which I can use as a mask. So that's why I have created these high poly versions, and I must create high poly versions for each part, basically, because doing this and trying to modify it so it fits all of the parts is infinitely harder to do. But that's another topic for another time. So this is how interlocking bricks and future proofing is intended to be done. As you can see, this is why I am constantly telling you to check and see if pieces work together, because otherwise, if you don't check, you will run across problems like so. Right? Right. Okay, so this was the end of the tutorial. See you in the next one. Bye.